With a mechanical watch, the parts inside are always moving and interacting with each other. But there are only a few occasions where you, as the user, the wearer of that watch, gets to interact directly with the movement components. With an automatic watch, wearing it will keep it wound by moving your arm so that the oscillating weight will wind up the watch. Other than that, the only direct interaction will be through the crown. That's how we wind and we set a watch. If you have a mechanical, manually wound watch, that means you actually have to turn the crown in order to wind up the mainspring to power the watch so that it will run. And you do that with the crown. The crown is directly attached to a movement part. And this is how you can access and control the movement within the watch case. With an automatic watch, you won't necessarily be winding it all the time. However, you will have to adjust the time, set the date, maybe set some other functions of the watch, and that also is done through the crown. That's why I want to take a minute to discuss what is happening, what components we're actually moving when we pull the crown out on a watch, or when we turn the crown and wind it up. It's helpful to not only know the names of those components, but know how they interact with each other. Because then you can understand what's happening and what might be a potential issue. Oftentimes I will hear that a watch is not winding properly or not setting properly. Usually I'll just be told that a watch is not running or it won't wind. And it might actually be something completely different. And it has nothing to do with the crown or any of the winding or setting mechanism. And by knowing a little bit about this one small part of a mechanical watch movement, it'll help you diagnose any issue and also give you a better understanding of how those parts are functioning and how they move within the watch. So first you have the crown itself, and the crown is the part of the watch that is on the exterior. That is the little knob that you can actually grab on the outside of the watch. And usually there's a position which is position 0, and that would mean that that is where the crown should be when you're wearing the watch. That would be all the way in towards the case, possibly screwed down if it's a screw down crown. Then you have position 1, position 2. There could be other positions depending on how many things you can do with the crown of that watch. We're going to talk about just a mechanical, manually wound watch. It's the simplest setup you can have for winding and setting of a watch, but it's the best place to start. So for a manually wound watch in position 0, that's going to be where it's all the way closed to the case, so you have a nice water-resistant fitting of the crown with the case. That's also where you're going to wind the watch. And winding the watch will be done just in one direction. Turning the crown clockwise will transfer power to the mainspring. The mainspring is inside the barrel, and that's where the energy is held. If you turn that same crown the other direction, counterclockwise, there is a mechanism that will allow it to turn backwards, but it's not actually going to do anything. So clockwise will add power to the mainspring. If you spin it the other direction, you'll hear some clicking noises, but it's just a clutch releasing. There's no power transfer into the mainspring. If you pull the crown out one position, you'll hear a click. That one click that you hear when you pull the crown out, that is engaging the setting mechanism. The setting mechanism is how you'll be able to turn the crown to align the hands to the time that it is. So that's how you set the watch through the crown. The crown is attached directly to a stem. The stem goes into the watch, and on the stem, you'll have a winding pinion, which is the gear that will actually rotate with the stem to interact with a few other intermediate wheels that will wind up the mainspring. The next component that is attached to the stem is a sliding pinion. Now, the sliding pinion moves back and forth depending on whether you're in setting or winding position with the crown. So when you're in setting position, the sliding pinion will move into the center of the watch, and it will interact with a setting wheel. And this setting wheel will transfer power to possibly an intermediate setting wheel, a minute wheel, an hour wheel, and this is how you will set the time. That gear train will be able to be pushed forward or backwards to move the hands of the watch. There is also a component called the cannon pinion, and the cannon pinion is what connects the gear train of the watch to the setting mechanism and the hands. So this component is a friction tight component on the dial side of the watch. So when your watch is running regularly, the hands will be attached to the cannon pinion, and the gear train will be connected solidly. When you change to the setting position, you're able to turn the crown, and you can break free that connection, that friction tight connection between the cannon pinion and the center wheel or gear train, and you can push the hands forward or backwards without moving the gear train, because the gear train is set. So it's similar to setting a clock, maybe a grandfather clock, where you might actually take the hands and physically grab the hand and move it. You're actually breaking it free with a cannon pinion, which is friction fit to attach to the gear train. And you overcome that friction fit when you use your fingers to move the hands. In a wristwatch, you'll use the crown to move the hands. So from the crown and a series of moving components within the setting mechanism, you're able to switch from that winding train to the setting train. And those are the two simplest functions that you have with a watch crown. There's also one other part that can be mechanically tied to the setting of a watch. If you've heard the term hacking seconds, what that means is that when you pull the crown out to set the time, you will actually be able to stop the second hand and keep the movement from running. This allows you to stop the second hand of the watch and sync it exactly to another clock or a reference clock. So for things where you're trying to be extremely accurate, or you're trying to be in sync with somebody else's clock, for instance, if you were a fighter pilot and you're syncing your timepieces with the other fleet of pilots prior to taking off and running a mission, it would be very important that all of your clocks or watches are synced up as accurately as possible to the second. Same thing with railway conductors. You would want to make sure as a railway conductor that your pocket watch is synced up to a reference clock, and then everybody else on the train line that is working will also be syncing their pocket watch to the same reference clock, so that everyone is on the same time within a very close tolerance. It does matter how accurate your clock is and your watch. However, everyone will be able to start the shift at the same exact time to the second. The hacking mechanism is usually a lever or a series of levers that will connect the crown of the watch to the balance wheel. And it will physically touch the balance wheel when you pull the crown out in order to stop the watch. There are other ways of doing it, I have made a watch that has a 0 reset hacking mechanism. And what that means is that when you pull the crown out, the second hand will run until it reaches 0. And at that point, it is physically being stopped by a lever so that you don't have to sit there and wait to try and pull the crown out right when the second hand gets to 0. You can simply pull the crown out at any time, and if you wait, the second hand will stop at 0. Those are the two most common hacking mechanisms. Either pulling it out for an immediate stop of the balance wheel, or pulling the crown out for it to stop at 0, for a 0 reset hacking mechanism. So now that you know quite a bit more about setting and winding, next time you pull the crown out on your watch, you'll know exactly what each click happening inside the mechanism is doing. You will know exactly how the movement pieces are interacting, and you'll know exactly what you're controlling. There's a lot going on when you pull the crown out or when you wind the watch, but now you'll know exactly what is happening inside of the movement when you're changing the time.